Today we are going to look at the frequency analysis. So we can open this file directly, save this file as another name. Then we establish a new study. Make sure you're using frequency. By default, usually by default it's a static, but this time we're going to use frequency. Give the name, say tutorial 4. You can use this name as well, doesn't matter. Save your file. You want to save your file frequently, from time to time, to avoid any loss of data. Now you can see we have several 3 components. One is the shaft and bearings, right? Bearing components, right? You can see here we have some components being mated together, right? So this is how we can study this assembly. Now let's assign the material to the components. This time we're going to assign components from here. Use right click and apply material to all. You can select the steel 1020. Okay, you can also search here, right? So A is I 1020, right? So okay, apply, close. Now you can see material being applied here. However, you can see there's no material being assigned, right? No material being assigned in this component. All right. So then it is different. All right. Okay. So you can see there's no material being assigned in each of this components level, but in the simulation study, we have material being assigned here. Let's save the file. Okay, next, then we make a picture. So we can choose this face and this face, 2 faces to fix. Save the file again. Let's Control 7 to bring it to isometric view. You can also hide this one, hide all, or show all the fixed, right? So save again. So we can define some plot by using simulation options. Okay, by select default options, frequency. So by default, you may see it is for all mold shapes being selected. This time we're only interested in the first 5 model shapes. So you can also change those values to specify. Okay, so and we would like to see the result type as amplitude, and also use resultant amplitude instead of individual, right? So okay, and hit OK, save the file to make sure all settings are being set. Okay, after specifying what default plot, then we are going to create a mesh. So this is the mesh. Right click, create a mesh. We're going to just use the default setting, and also usually we accept the mesh, then this mesh will be created, and then we run the simulation. We can also ask the system to run the simulation after mesh being created. So let's do this. Make sure runs also the analysis being selected. Hit OK. So you can see mesh being created, and the tutorial 4 is being analyzed or solved. Then we have the result. Let's save the result. Okay, so you can see this is a first model. Okay, or say amplitude model shape 1. This model shape 2, model shape 3, model shape 4, model shape 5. Right, so each of this represents different mode. And we can also go to Result Advisor, and list redundant frequencies. That's a result. See here, right? So model 1, we have frequency about 3,370.1 Hertz, right? So mode number 2, what do we have? We have 3,390 and 0.5 frequency, and so on. Okay, we can save our file. Then later on we can view it in Excel file. Hit OK. So this one, we can go to result, list mass result, list mass participant. Right. So you can see here in X direction, which is in X direction, it is very small, 0.07. In Y direction, which is going up and down, it is 0.19. And in Z direction, which is in X direction, is 0.29, or around 0.3. Okay, so you can see we can also save this file for later analyze. Okay, so you can see. Okay, so we can also check the accuracy of the results by remeshing it. this time I'm going to copy the start instead of remesh it directly. So this time you can see tutorial 4 is being copied, right? So will be copied, and frequency. So the start name, we're going to say starting name. We're going to say remesh. Hit OK. Alright, so remesh from tutorial 4, and if you nothing will change it at this moment, save it first, then we're going to say create mesh, right? So warning is being given. It says remeshing will delete the result for study. Okay, so hit OK. So this time we're going to use mesh size global. This is global, right? So this is tolerance. So we're going to use you can use this one to make adjustment, or you can type the value directly. Okay, so option run so, right? So run. Okay. Okay, a new result is being given. Let's save this one. Okay, now we have results. Then let's look at the frequency as well. So you can see here we can save those frequency. Now we can see one is 3,360. This one is 3,370. There are some variations, okay, but not very large. Okay, now let's hide all the fixed, and then we can right click amplitude, and then we can edit definition, and this time we're going to deform shape, and uncheck show colors and hit OK. You can see the deformed shape is given but not showing the colors. Save the file, Control 7 to bring it to isometric view. Okay, now we can also see the undeformed shape, right? So in the similar starting tree, right click amplitude, and select setting, simulation tree, study tree, settings. All right, so and select the unsuppressed model, right? Okay, we would like to display this one, right? And we can edit color, say blue, hit OK, and then translucency, right? So let's say make this one to be 0.75, and let's say hit OK. Now what you can see here, that undeformed shape or original shape is given here, right? So let me see, change it to another different color. It's not very clear. Okay. Save the file. Okay. So we can also see other results. If you want to make it similar undeformed, then you need to change the settings for each of this, right? For example, okay. All right. 1.75. Hit OK. Right. Save the file. This is the end of the frequency analysis tutorial.